Hello everyone, today we're going to simplify radical expressions. So, a radical expression is in its simplified form if there is no radicand, contains a fraction. Next, number 2, no denominator contains a radical sign. Okay. So, in order for that to simplify our radical expressions, we're going to rationalize the denominator of the radical, and that process is what we call rationalization. This is the process of removing the radical sign in the denominator. So also, we're going to make use of the quotient rule for radicals, wherein if a is greater than or equals to 0 and b is greater than 0, then the nth root of a over the nth root of b is equal to the nth root of a over b, or vice versa. So this is the quotient rule for radicals. Okay? So, let's say for example we have square root of 16 over square root of 4. So using the quotient rule for radicals, we have square root of 16 divided by 4. So 16 divided by 4 is 4. So we have square root of 4. We all know that square root of 4 is 2. Next, number 2, let's say we have square root of 10 over square root of 2. Again, using the quotient rule for radicals, we have square root of 10 divided by 2. So we have here square root of 5, because 10 divided by 2 is 5. Now, since that 5 is a perfect square, so this is the answer, square root of 5. Now, number 3. Let's say we have square root of 9, a raised to the 4th power, over square root of 16b raised to the 4th power. Now, what did you notice to the numerator and to the denominator? So, as you can see, the numerator is already a perfect square. Okay? So, square root of 9 is 3. Then, square root of a raised to the 4th power is a squared, right? So, we have 3a squared. Then, over square root of 16, we have 4. And then, square root of b raised to the 4th power is b squared. Because you divide 4 by the index 2. Okay? So, this is the answer for number 3. Next, number 4. Let's say we have the cube root of x raised to the 9th power over the cube root of x raised to the 5th power. Okay. So, using the quotient rule for radicals, we have cube root of x raised to the 9th power over x raised to the 5th power. Again, using the laws of radicals, the quotient rule for exponent, we have to subtract the exponent. So, we have 9 minus 5, we have 4. Okay, so we have the cube root of x raised to the 4th power. The next, we're going to factor this radical. So we have to factor x raised to the 4th power, wherein one of its factors is a perfect cube. We have cube root of x cube times the cube root of x. So from 4, you're going to think of a number less than 4, which is divisible by the index 3. So that is 3, right? Next, this is a perfect cube factor, and this is a non-perfect cube factor. So what are we going to do is we're going to simplify the radicals. We have cube root of x raised to the third power. We have x, okay? Then times the cube root of x. So you will just copy this one, okay? The non-perfect cube factor. Next, number 5. Let's say we have square root of 12 over 25. Now here, you cannot divide 12 by 25. So what are you going to do is, you're going to make use of the quotient rule for radicals. You have a square root of 12 over square root of 25. Then after that, you're going to factor 12, wherein one of its factors is a perfect square. So we have square root of 4 times square root of 3. Because if you're going to multiply 4 times 3, we have 12, okay? Then, square root of 25 is 5. The next we have, square root of 4 is 2. Then, you will just copy square root of 3. Then, over 5. So, this is the answer for number 5. We have 2 square root of 3 over 5. Next, number 6. Let's say we have square root of 9 over square root of 2. Okay, so as you can see, 9 is a perfect square, right? We have square root of 9 is 3, then over square root of 2. But then, a simplified form of a radical, or as a radical is in its simplified form, if there is no radical in the denominator. We have here radical, which is square root of 2. Now, what are we going to do is, you're going to rationalize the denominator. So here, you're going to think of a number that can be multiplied by 2 to make it a perfect square. So in this case, we're going to multiply both sides, both the numerator rather, and the denominator by square root of 2. Okay? Because if you're going to multiply, 2 times 2, we have 4. 4 is a perfect square, right? So here we have 3 times 1 here as a numerical coefficient. So we have 3. Then you will just copy square root of 2. Then over square root of 2 times square root of 2 is, we have square root of 4. So that is 2. So you will just copy the numerator, 3 square root of 2, then over 2. Now you cannot divide, you cannot cancel rather, 2 and then 2, the square root of 2 and then 2. Because they are not similar terms, okay? So the answer is 3 square root of 2 over 2. Next, number 7. Number 7, let's say we have cube root of 81 over cube root of 2. Okay, so here in this case, you have to factor cube root of 81. So we all know that 81 has a factor wherein one of its factors is a perfect cube, which is 27, right? So we have cube root of 27 times cube root of 3. Okay? Then all over, we have cube root of 2. Okay. Then cube root of 27 is 3. Then this one, you will just copy cube root of 3. Then over cube root of 2. Okay. So here in this case, notice that there is a radical in the denominator, which is not, we can say that this is not in simplest form, right? So again, we're going to rationalize it. we're going to multiply both the numerator and the denominator by cube root of 2 squared. Okay? Why? Because if you're going to add the exponents of this factor, we have 2 and then 1, the result is 3, which can be divided by the index 3. Okay? So, we have here 3 times 1 here. So, we have 3. Then, cube root of 2, or 3 rather, times 2 squared is 4. Okay? Then, over cube root of 2, you will just now add 1 and then 2. So, we have 3. Okay? Then, the answer here is, let us make another. Okay. Then, this is now equal to 3 cube root of 3 times 4, we have 12. Then, over cube root of 2 cube is 2. Okay? So, this is now the answer. Okay? So, we have 3 cube root of 12 over 2. Okay? Next, number 8. So, number 8, let's say we have square root of 3 over square root of 7. Okay. So, the numerator is not a perfect square, also the denominator. So, what are we going to do is we have to rationalize the denominator. So, we have to multiply this by square root of 7 over square root of 7. Then, multiply 3 times 7, we have 21. So, square root of 21 over square root of 7 times square root of 7, we have square root of 49, which is 7. Okay? So, this is the answer for number 8. Okay? Next, number 9. Number 9, we have x over square root of 3. Now, again, square root of 3 is a radical. So, this is not yet in simplest form. So, we have x over square root of 3, multiply it by both the numerator and the denominator by square root of 3 over square root of 3. So, we have x times 1, we have x. Then, you will just copy square root of 3 over square root of 3 times square root of 3, we have square root of 9, which is 3. Okay? So, this is the answer for number 9. Next, number 10. Let's say we have cube root of 7 over 2x. Okay. So, let us make use of the quotient rule for radicals. We have cube root of 7 rather over cube root of 2x. Okay. So, here, again, we have to rationalize this. We have to multiply both the numerator and then the denominator by, to make it perfect cube, 2. We have 2, the new exponent is 1. So, we have to add 2 to make it divisible by the index 3. So, we have 2 squared, right? Then, for x variable, again, we're going to make it, we have x squared, okay? Next, we have here cube root of 7 times 2 squared is 4, then times x squared. Okay, so we have x squared over cube root of, we have 2 cube because we add the exponent. So we have 1 plus 2, we have 3. Then for the x variable, the same, we have 1 plus 2, we have 3. Then we have here now cube root of 7 times 4, we have 28. Okay? Then x squared. Then over cube root of 2 cube, we have 2. Then cube root of x cube, we have x. Okay, so this is the answer for number 10. So that's it for today. Simplifying radical expressions. Now, don't forget to like, subscribe, comment, share, and click the notification button for more videos and updates. Thank you.